the Singapore University of Technology and Design, in collaboration with StarHub, Synergy Design Technology, and VIAVI Solutions, presents the deployment journey of an ORAN-based enterprise 5G solution, from lab testing and integration to real-world field trials. In this demo, we conducted a lab testing on Synergy G Node B using VIAVI Test Suite, a field trial with Synergy's Open RAN G Node B, connected to StarHub's live 5G core. On top of that, we developed a drone and a robot use cases that are running on the ORAN-based enterprise 5G solution. Firstly, for the lab testing, we conducted selected test cases from ORAN's end-to-end functional and performance tests. On top of that, we performed a customized test, simulating the uplink video streaming behavior of the drone and the robot use cases. In the lab test, we used VIAVI ORAN testing tool, which includes the VIAVI TM500UE emulator, VIAVI Tira VM 5G core, and Tira VM real data application. The system under test consists of Synergy Design's OCU, Synergy ODU, and an ORU, which is connected to the UE emulator's RF card via RF cables and attenuators. A laptop connected to the UE emulator is used as a pass-through UEE, and an N6 application server is connected to the Tira VM 5G core to run customized applications, such as perf traffic and uplink streaming. For the downlink test, a downlink UDP traffic is run from the UE emulator laptop. A peak downlink throughput of 596 megabit per second is achieved. Similarly, for the uplink test, a peak uplink throughput of 77 megabit per second is achieved. For the customized uplink video streaming test, we performed an uplink video streaming from the UE laptop to the N6 streaming server. We analyzed the traffic profile and determined that the Open RAN setup is able to support multiple high-resolution uplink video streams. The following test cases are completed during the lab tests. Secondly, for the field trial, we performed security hardenings on the Synergy's RAN and connected the setup to StarHub's live 5G core network. The connection is secured with an IPsec connection. An ORU and AUE are placed in a shielded box to measure the end-to-end performance over the air. For this, we achieved a downlink throughput of 505 megabit per second and an uplink throughput of 67 megabit per second. The result is consistent with the lab test result done with the VIAVI testing tool. As part of the field trial, we included a site survey of the aerial arena at SUTD. We extended an ORU to the SUTD aerial arena at level 7. First, using a 5G dongle connected to a laptop, we measured the latency and throughput along the courtyard corridor that surrounds the aerial arena. Next, using a drone, we measured the latency and throughput when the drone was hovering in the air at predefined points. From the field trial, we determined that the Synergy Open RAN setup, connecting to StarHub's 5G core, is capable of simultaneously supporting uplink heavy video streaming robot and drone use cases, which we used for the live demo. Thirdly, for the live demo, we developed a 5G surveillance robot with AI object detection. Upon detection of a suspicious object, an operator is able to take control of the robot manually over the 5G Open RAN and remove the object from the scene. This use case can be deployed in public spaces for suspicious objects detection and removal. We also developed a 5G metaverse drone application, where the drone pilots fly the drones remotely, navigating virtual objects collecting points. This application can be used to train drone pilots. We conducted the live demo for the robot and the drone use cases from StarHub HQ. For the live demo, the drone and the robot are connected to the Synergy G Node B at SUTD. The Open RAN setup is then connected to StarHub's 5G core. The control of the drone and robot is done remotely from StarHub HQ via the internet. The drone pilot is able to receive the drone's telemetry and status, as well as the drone's live video stream remotely. The drone can be controlled remotely. Likewise, the robot operator is able to receive the robot's live video stream, SLAM map and controller status. Upon detection of the suspicious object, the robot operator takes control of the robot remotely and bring the object to a designated area. This end-to-end demonstration highlights how ORAN-based 5G technology ensures reliable performance across both controlled lab settings and real-world applications, paving the way for smarter and more efficient enterprise and security operations.